Hi everyone, this is going to serve as a brief tutorial as to how to interpret a phase diagram. These diagrams are not very complicated, but they are very interesting and they tell us a lot about a compound or a substance. So what we're going to go through is how we can predict possibly what phase something like carbon dioxide or methane or anything like that would be in given temperature and pressure. So just to review, here's some various phases here. Right, so solid phase at the bottom, cold temperature generally, molecules not moving very much, very structured, held tightly in place. Then we transition as temperature goes up to a liquid phase, temperature rising, go to a gas phase. Beyond that, you go to a plasma phase, where you actually have free electrons and ionization happening. So we're going to talk about these transitions in terms of pressure and temperature because both of them come into play. What I'd like you to think about, maybe for your test, is it easier to boil water on a mountain? And if so, why? So think about that. All right, so I'll leave you with that. All right, here we go. Phase diagrams. This is what they look like. We looked at one when we had our demonstration in class with the dry ice. So what can we see? We see pressure on the vertical, or what we usually call the y-axis, and we see temperature along the horizontal, or x-axis. Not drawn to scale, obviously. This is the one for CO2. Let's talk about some parts of it, okay? So you have this triple point. Well, let's just talk about the basics here first. So see these lines here that I've now butchered. Those lines represent phases and change in phase. So to go from a gas to a solid, from a solid to a liquid, you're going to cross those lines. So for instance, on a test, if I said, what's happening right here? You're going either from a solid or a gas, and whatever that transition might be. And we'll talk about those in class, and you should be doing those for your self-study also. So those are going to be transitions. So for instance, if it was from a solid straight into a gas without going through the liquid phase, that would be sublimation. If it was the other way, I'm not even going to say. You're going to look it up. Anyways, so you need to know both ways. So you need to know things that are going, from a solid to a gas, and then also from a gas to a solid, and then from a liquid to a gas, liquid to a solid, and so on. So you need to know all those transition terms. And now let's talk again about what's happening in this phase diagram. So, triple point. Triple point is insane. It's so cool. I'm going to actually try to find a demonstration or a video or something to show the triple point. In thermodynamics, which is what we're talking about here, so thermo being temperature, dynamics being changing. In thermodynamics, this is where the three phases exist in equilibrium. So you're going to have an equal amount of whatever, in this case CO2, in all three, solid, liquid, and gas. All three phases exist at equilibrium at that pressure and that temperature. That is the triple point. At the other end, well, not at the other end, but up here, we have a critical point. The critical point is where an equilibrium stops, okay? So along here, along these transitions, you have an equilibrium. You'll have equal parts water, equal parts gas, say. So between here and here, equal parts liquid, equal parts gas. At this point, we can't predict that anymore. It's the end of the equilibrium. So that's the critical point. So at that point, both liquid and gas coexist at the same time. Okay? So it can be both of those at the same time. It all has to do with pressure and temperature. Now, these phase diagrams, this is the one for CO2 I said, but they all look a little bit different. So if I give you one that's maybe not labeled or for a different chemical, you should be able to interpret it. It's always going to go solid, liquid, and gas in this way. And I think you can figure that out even just from the temperature scale. It's always going to go solid, liquid, and gas. So looking at this one from CO2, you can see that we know that you can't have liquid CO2 necessarily under our atmosphere. And that's because we're here. We're at 1 atmosphere, usually. And so at that point, at a normal temperature, say room temperature, 20, 22 degrees Celsius, if we draw the line there, right about there. You'll notice that it's in the gaseous form. So at room temperature, if I have CO2, which we had in class, it'll be in a gaseous state. It's in the solid state as dry ice because we bring it down to about minus 80 degrees Celsius. So it goes into a solid state, no problem, under our atmospheric pressure, because that brings us right here. Okay, so those would be things that you'd have to interpret. No big deal, just looking at the graph, understanding that the lines mean transitions, what state you might be where, and definitely knowing the triple point and the critical point. Understanding this is pressure and this is temperature. Okay, so on a test, what would it look like? I might give you something like this. Okay, the graph looks good. The the axes look kind of wonky, but they'd look better on a test. But here we have our pressures again, and here we have temperatures down here. So down here we have temp, and here we have pressure. Okay, pressure could be in any units. Okay, there's different units for pressure. We're talking about in class. It'll be ATM, KPI, PSI, ATM, millimeters, HG, whatever you want. But we'll stick to atmospheres for these guys. And then temperature at the bottom. So if I asked you, given this, say this is a phase diagram for, I don't know, based on those temperatures. I was about to say water, but based on those temperatures, there's no way. But say this is the phase diagram for, I don't even know. Let's just say it's for mercury. It's not. We're going to say it is. So for this, or maybe just for this unknown, let's say for this unknown substance, at 1 atm and 20 degrees Celsius, what phase would you expect it to be in? So 1 atm, this isn't really drawn to scale, but it's definitely down here somewhere. Okay, I'll go back to my green. Definitely down here somewhere. 20 degrees Celsius is here. Okay, so based on that, what phase would you be in? You'd be here, be in this C zone, and we know that it goes solid, liquid, and gas. Okay, so you'd be in a gaseous state. That's it. I might ask you, what is E? You'd have to say E is the triple point. Or I might say, what is the triple point for the substance? You'd have to say, well, I don't know, this graph is kind of, again, off, but you'd have to say, I don't know, 4.5 atm and 0 degrees Celsius. So you'd have to, use the graph, interpret it, make sure you memorize what triple point is and a critical point is. And again, I'm going to try to find a great demonstration for the triple point because it is so cool. Other than that, that's it for phase diagrams. So you should be pretty comfortable with those. You have one in your note package. So add some notes to it, quiz yourself, quiz your friends, and you guys will be fine. Thanks.